Hello everyone, myself Sindhashri and I am studying second year engineering in Sri Venkateshwara College in CSE branch. Today we are going to discuss about a topic called hanging chain problem. At first, before going to the problem, let us discuss what is hanging chain. Hanging chain means if a chain or a cable has its ends fixed at two different points and hangs under the influence of gravity. It takes the shape of hyperbolic cosine curve. As we all know, hanging chains means the chains which are hanged between 2 points. Here in this theorem, they are going to prove that this hanging chain takes the shape of hyperbolic cosine curve. Okay, now let us go to our problem. Our problem topic is a heavy cable hangs freely under the gravity between two fixed points. Show that shape of the cable is catenary. What is the statement of our problem is a heavy cable hangs between two fixed 2 points and we have to prove what that shape of the cable is catenary. Before proving, we have to understand what is catenary. So catenary means a wire or a cable fixed between 2 points which are flexible but not stretchable. Means 2 points are there. They are fixed. They are more flexible because they can come up, down, everything, but they cannot be stretched. This statement is called catenary. The potential energy of hanging chain is minimum if it is a catenary. The potential energy of this particular chain is minimum if that chain has a catenary. Okay, then the equation of catenary we have to obtain is y is equals to a into cos h x plus c2 by a, where c2 is some constant value. Okay, let us discuss our problem. It is the diagram of our problem where point A and point B are the 2 points which are fixed, and let P of x comma y be some particular point. Okay, then y is equals to h is the height between that point to the x-axis. Okay, let a of x1 and y1 and b of x2 and y2 be a fixed points of a subspecies of the chain. Okay. Consider an arc element ds at a point p of x comma y of the chain. This arc ds is like we have divided that chain into small part. So let us that small part is called ds. Okay. If rho is the density of the chain, then the potential energy at P of x comma y is given by mgh. If rho, we have to consider the density, like on that point, if rho is density, then the potential energy it is defined by mgh, which is equals to, where m is equals to rho into ds, and g is the gravity, h is height as we defined in our figure. Then total potential energy of this curve is given by y is equals to, okay, our potential energy is given by capital V. Let us consider capital V as our potential. Capital V is the potential energy, where capital V is equals to integration of A to B rho gy into ds. This is the general equation of any potential energy. So according to this figure, potential energy is equals to integration from x1 to x2, where A of x1 from there to B of x2 till there, rho into g into y, that is mass and gravity, into ds. ds means it is a density, where some point where if we derive the arc length with respect to x is given by ds by dx into dx. Like if we integrate into dx, in the right side I have written that ds by dx is equals to root of 1 plus dy by dx square whole square. This is the general equation for if we derive the arc length with respect to x. So where dy by dx is y dash. Have represented y dash as y1. So ds by dx is equals to root of 1 plus y dash square. Therefore, total potential energy is equals to integrated from x1 to x2 rho into g into y into root of 1 plus y dash square into dx. This is our total potential energy. In the same, so the above equation is total potential energy. In the same way, now we have to evaluate the value of y, where in total potential y is empty. So we have to evaluate that value. So we have a function f. F is equals to rho into g into y into root of 1 plus y dash square. From Euler's equation, as we all know, Euler's equation says that dou f by dou y minus derivative of dou f by dou y dash is equals to 0. Where dou represent it is a partial differentiation. Means we will differentiate the f by only y factor as in the dou f by dou y. In the case dou f by dou y dash, we will differentiate the equation f by y dash. Okay. But in the above, what we obtained in the above equation, f is independent of x. So, the alternate form of Euler's equation is given by f minus y dash into dou f by dou y dash is equals to 0. This is the alternate form of equation, Euler's equation. So according to this equation, let us write the values. As we all know, f is rho into g into y into root of 1 plus y dash square. Copy that value to in the place of f. Then minus y dash as it is. Then dou f by dou y dash. So we have to differentiate the equation f, that is rho gy into root of 1 plus y dash square. We have to differentiate with respect to y dash. So in that purpose, rho gy is constant. So we'll write it outside. Okay, rho gy into differentiation of root x or any root term is 1 by 2 root x. In the same way, differentiation of root of 1 plus y dash square is 1 by 2 into root of 1 plus y dash square. Again, after differentiating the root, then we have to again differentiate the inner terms. So we have to differentiate y dash square. Differentiation of x square is normally 2x. Okay, so differentiation, the first inside one term 1. So the differentiation of constant term is 0. So into 0 plus differentiation of y dash square is 2 into y dash, which is equals to constant c1, any some constant. Okay, then take rho into g into y common from both the sides. Okay, rho g1 common, root of 1 plus y dash square minus 1 into 0 0, so 1 into 2 into y dash, then again down 2 into root of 1 plus y dash square is there, so 2 gets cancelled. So y dash divided by root of 1 plus y dash square. Everyone may confuse how y dash square came in the numerator. Don't get confused. Here we have taken only rho gy as a common. So remaining y dash is there in the subtraction term. So y dash into y dash is equals to y dash square is equals to c1. Then we have to take LCM in that bracket. So if we multiply root 1 plus y dash square into root 1 plus y dash square, it becomes 1 plus y dash square minus y dash square divided by whole to the whole root. So root of 1 plus y dash square is equals to c1. So by alternating the above equation, we get rho into g into y divided by root of 1 plus y dash square is equals to c1. Or we can write this equation as y divided by root of 1 plus y dash square is equals to c1 by rho into g, where c1 by rho into g is considered as a. Okay. Then squaring on both the sides, we get y square divided by 1 plus y dash square, because when we square, root gets cancelled. So we'll get 1 plus y dash square is equals to a square. Then by alternating this above equation, y square, like we'll multiply the denominator into the RHS sides of for a square. So we'll get y square is equals to a square into 1 plus y dash square. Again, if we multiply a square in both the inside the bracket, we'll get a square plus a square into y dash square. Then y dash square is equals to, by interchanging the terms we'll get y square minus a square divided by a square. Then taking square roots on both the sides, we'll get y dash is equals to root of y square minus a square divided by a. Then y dash is similar to the derivative of y. So we'll write y dash as dy by dx, which is equals to root of y square minus a square divided by a. Then separating the each variables, that is multiplying dx into the right side RHS. So we get a into dy divided by root of y square minus a square is equals to dx on integration. Like we have to do integration on the both the sides. So a is constant term. So we'll write a as it is. So a into integration of dy divided by root of y square minus a square is cos h inverse of y by a. This is the standard formula in the integration. Remember, integration of dy divided by root of y square minus a square is cos h inverse of y by a, which is equals to, again, integration of 1 into dx. If any number is not there, then we'll consider 1 is there. So 1 into dx is x. This is the standard formula in integration. 1 into dx is equals to x plus integration constant c2. By again rearranging the term, we'll write cos h inverse of y by a is equals to x plus c2 divided by a. Then transferring the cos in h inverse to the RHS, we'll get cos h. So we'll write y by a is equals to cos h of x plus c2 divided by a. Hence, we obtained a catenary equation, that is y is equals to a into cos h of x plus c2 divided by a. This is the catenary equation. So our task is proved. So what they have asked, we have to prove that the cable wire is catenary. So we obtained our equation, hence our task is completed. And thank you for watching the video. Thank you.